Hello, it's Dave Giles here for the next lesson of Cambridge International Education IGCSE Physics, and we're looking at the electricity and magnetism unit. And today we're looking at resistance in a length of wire. So only describe the relationship between area, length, and resistance, and use the relationship to calculate resistance. So, quick question. I've got some conducting blue tack. Blue tack, which is a conductor, but does have some resistance. Without changing the material, so I can't add or take it away. I can't change the kind of blue tack I'm using, so I can't change the material or the battery. How can I increase or decrease the resistance of the circuit? Give you a few seconds to think about that. Okay, there's two ways you can do it. And one of them is to stretch it out thin. So roll it, have it long and thin, because then you've decreased the area and you've made it longer. So that will increase the resistance. Alternatively, you can squash it, make it a bit shorter, a little bit fatter, and that will decrease the resistance. So it's effectively like resistors in series and parallel. If I roll it long and thin, so I've got 300 ohm resistors, by adding more resistors in series, the electrons effectively got a longer path of resistance, so their resistance increases. Whereas when I add them in parallel, the electrons have got more different paths that they can travel down, so the resistance actually decreases. So 300 ohm resistors in parallel, the resistance is going to be less than 100 ohms, it's going to be about 33. Whereas in series, when I put them like this, it's going to be about 300 ohms, so the resistance is multiplying here, whereas it's dividing here when I add more resistance. And that's just like the conducting blue tack I had earlier. If I make it long and thin, that's like adding more resistors in series. If I make it short and fat, that's like adding more resistors in parallel. So you need to know that resistance is proportional to length, and resistance is inversely proportional to area, or resistance is proportional to 1 over area. Combine these together and you get resistance. It's proportional to length over area, or K, which is a constant, times length over area. Now, when you move to A level, you'll learn about resistivity, but when you do not need to know that at IGCSE yet. So using these equations here, also mainly this one, resistance is proportional to length over area. Have a go at these questions here. So a 10-meter length of wire has a resistance of 20 ohms. Calculate the resistance if the length of wire is 30 meters. So I've just multiplied the length by 3 or tripled it. So 20 ohms times 3 is now 60 ohms. Now I've halved the original resistance, sorry, half the original length. So I also half the original resistance. So 10 ohms. Give you a few seconds to have a go to C, D, and E yourself, or pause it. Okay, put the answer on for C, D, and E. Now, a wire, an area of 4 millimeters squared has a resistance of 25 ohms. Calculate the resistance of the wire if the area of the wire is 8 millimeters squared. So here, resistance is proportional to 1 over area. The area has doubled. So 8 millimeters squared is 25, the original, times 1 over the how many times we've increased the area, or we've doubled it, so 1 over 2. So it's 12.5 ohms. Likewise, here, I've now halved the area. So resistance is now 25 times 1 over a half. So it's 50 ohms. So I've now doubled the resistance. Pause it, have a go at the other two yourself. Over 3, sorry. Okay, and I'll put the answer on now. Finally, I'm now combining these equations. So a 4 length of copper wire with a cross-sectional area 6 millimeters squared has a resistance of 9 ohms. Calculate the resistance of the copper wire with a cross-sectional area 6 millimeters squared and a length of 6 meters. So length of wire has increased 1.5 times. So resistance is 9 times 1.5, 13.5. Now we've changed the cross-sectional area, and the length is still 4 meters. So for the first one, we increased the length, kept the cross-sectional area the same. Now we are changing the cross-sectional area, but keeping the length the same. So area of the wire is also increased 1.5 times. Resistance is equal to 9 times 1.5. So 9 times 1 over 1.5, 6 ohms. Now combine these two things. We've changed the cross-sectional area and the length. Length of wire has increased 0.75 times. That's the same as saying it's decreased. Area of wire has increased 0.167 times. Resistance is proportional length over area. Resistance is 0.75, because how many times length has increased, over the area has increased 0.167 times. So you get 40.5 ohms. Okay, so that's the questions that I kind of made up myself. Now have a go at these past paper questions, paper 2. Diagram shows a piece of metal resistance wire. Which wire made of the same metal has the smaller resistance? Start from the bottom. A wire of greater length with a smaller diameter. So it's greater length, so that means the resistance will increase. Smaller diameter will also increase that, so it's definitely not that. A wire of greater length with the same diameter. Well, the greater length is going to increase the resistance, so it's not that. A wire of the same length with a smaller diameter. Again, the smaller diameter is going to increase the resistance, so it's not that. A wire of the same length with a larger diameter. The larger diameter is going to decrease the resistance, so it's A. Oh, so I put that in the wrong order there. The diagram represents 4 copper wires. Which wire has the greatest resistance? So it's going to be the one that's the longest with the smallest cross-sectional area. So that is going to be C. Fine. And final MCQ. The resistance of a wire depends on its length L and its cross-sectional area A. The resistance is, let's go through them, starting from the bottom, inversely proportional to L and inversely proportional to A. No, because we've already said earlier that it's proportional to L, although it is inversely proportional to A, so the first half's incorrect. Inversely proportional to L, that's incorrect, and directly proportional to A, both parts are incorrect. Directly proportional to L, that's correct, and inversely proportional to A, that is also correct. So yeah, looking like the answer is B, but we'll double check A. Directly proportional to L, correct, and directly proportional to A, no, because it's inversely proportional to A, so the answer is therefore B. Okay, the next lesson is on power and energy, which I will be uploading soon. I'll post a link down below to it. Thank you very much, everyone, and I will see you in the next lesson.